Good day, grade 11 learners. Welcome to today's physical sciences lesson. My name is Mer Baloy. Welcome to today's technical sciences lesson. My name is Mer Baloy, and this lesson is proudly brought to you by the Gauteng Department of Education. Right. So, what are we looking at today? So, the knowledge area for today is mechanics, and mechanics counts out of 65 marks. So it is a topic that is obviously examinable in the final examination in grade 12. So please pay attention. Remember, we said that this is a bridge the gap session. So we are helping you in preparation for next year. So today's topic, or rather for today's lesson, will be mainly strictly focused on the Newton's second law of motion. So let us get started. Let us first look at the paper 1 mark allocation for your matric. So there is section A, and section A comprises of, which is the first question, and that is your multiple choice. And multiple choice is what? 10 questions, 2 per question, 2 marks per question. That means that we have 20 marks. So when you're dealing with multiple choice, grade 11s, please allocate enough time for it, because it's not always going to be straightforward where you will need probably 5 minutes to complete the whole 10 questions. No, some questions need application and you need to think about them. So please allocate enough time for this. The second one is section B. What does section B have? Section B is basically structured or long questions, and they're about 130 marks. Just to go back on the multiple choice, do know that multiple choice is basically everything. It will be multiple choice based on all the knowledge areas and the topics that will be covered. And then section B is basically your structured or long questions, and that's around 130 marks. That is going to basically cover everything altogether. And then the total mark for your final exam is, of course, 150 marks. So this 150 marks will be done in about 3 hours. So please, when it comes to time management, make sure that you allocate enough time per question. So let us now look at the topics that are covered in paper 1. We have mechanics, which we'll be dealing with today. So mechanics makes up the most, or has the most chunk of marks regarding your final paper. So what is covered in mechanics? In mechanics, we have the Newton's laws, and that's what we'll be looking at today. We've got the vertical projectile motion. We have the linear momentum impulse, and this is basically one topic altogether. Then we have work, energy, and power. So if you can master your mechanics, trust me, you're on a good start. And then secondly, you have a topic that is about the wave, sound, and light, and that's about 15 marks. And then we have the matter and material, which covers your photoelectric effect, absorption, and emission spectrum. So these two work in conjunction, right? So if basically when working with sound, we're working with what? Waves, right? So and also light, we're working with waves. So these two work hand in hand. So these are like the least of them all, which is like 15 and 15, that is about 30 marks. And lastly, we have electricity and magnetism. This is the second chunk of the whole paper. This counts out of 55 marks, and where you'll be discussing electrostatics, you'll be dealing with electric circuits and electrodynamics. So when we're talking about electrostatics, we're basically talking about all those charges and the Coulomb's law, and we will get to that within these sessions. For today's purpose, I did say we'll be focused on the Newton's laws of motion. Remember, the Newton's law are something that you need to master. It is a topic that was covered extensively, I believe, in grade 11, and we are going to revise on that regarding today. So Newton's laws play a very critical or important part of matric, because of they integrate with other topics. So they have a lot of implications as far as the other topics are concerned. So it is very, very, very important for you to master these laws and understand, and not only just learn them to understand, but also be able to apply these the forces and the Newton's law. So we'll start off by looking at the Newton's first law of motion. Do you remember what it is about? So the Newton's first law of motion, we are looking at an object that is basically what? It's not moving, it is at rest. So this is an object at rest or moving at a constant velocity. Keyword, it is at rest, it is not moving. Constant velocity should tell you that acceleration is therefore zero. It's not accelerating. Why is it moving at a constant velocity, or why is it at rest? Why does it maintain its original position or its original state? That is because of we're looking at an F net of zero. The net forces acting on that object amount to zero. Question for you. Does that entail that there are no forces at all? That is a no. There are forces, but it's just that the sum, the net, means that the total forces, when we then add them together, they will be zero. And that is the reason why this object will maintain its position, or it will maintain its original state of motion or move at a constant velocity. So when an object is not moving or maintains its position, what does that tell you about the forces? The net forces are zero. There are forces acting on the object. It's just that their sum amounts to zero. So now what is the difference between the first and the second law? The second law, we have, the first point is that the forces, the net force, do not amount to zero. They don't add up to zero. Because of there is a net force, therefore we will experience acceleration. And you will see when we discuss it extensively that when the object accelerates, it will accelerate in the direction of the force, of the net force. So because of we have a force in this case, so the net force is not equals to zero. What does that tells you? That all the forces summed up together will not equals to zero. So there will be a force, and therefore there will be an acceleration. So the major difference between the first and the second law is that the first one, in the first law, the sum of the forces, they give us zero. In the second law, the sum of the forces, they do not equals to zero. So there is force there that will cause an object to accelerate. Here, the object in the first law, the object moves at a constant velocity. What does constant velocity tells you? It tells you that the acceleration is zero. Do you remember from grade 10 when we did the graphs of motion? And we're looking at acceleration with we had v over t. If we had velocity that was constant, what did that tell us about acceleration? Acceleration would be zero. Why would acceleration be zero? That is because of the gradient of this graph, which is going to be a change in y over change in x. The gradient of the graph should give you acceleration. But if we have the same number throughout here, so if I have, in this case, in the x-axis, let's take this was 4, for instance, for argument's sake, we have a 4 there. So the change in my x would be 4 minus 4. And the change in my y, the change in the y would be 4 minus 4, right? Whereas the change in the x, let's take for t1 and t2, would have 2 minus 1, for example. So would still have 0. So that would be my acceleration would therefore be 0, because it would be, we would have, if you take your calculator and you say 4 minus 4 over 2 minus 1, what do you have? You have 0, because you'd have 0 divided by 1. So constant velocity tells you that acceleration is 0, or rest. You know you're dealing with Newton's first law. When we then have an acceleration, that tells you that the net force is not 0. It does not add up to 0. So there is an acceleration. And when we're looking at Newton's first law and second law, we are still looking at single objects. Now we introduce the third law. The third law, now we are looking at more than one object. So now we're looking at, for example, 2 bodies in this instance. So in the third law, we are told that we are having 2 bodies that exert forces on each other, but in opposite, they act in opposite sides. So we have object A that exerts a force on B, and we have object B that exerts a force in equal magnitude, but in the opposite direction on object A. So just what you need to take from this is that when you are dealing with Newton's laws and you are confronted with a problem, you need to please look for keywords. Keywords will help you understand or assist you to know which law are you exactly dealing with. Keywords, for example, when you're looking at if the question has something to do with constant velocity, you know that you're dealing with the first law. If it says the object is at rest, you know that you are dealing with Newton's first law. When you're looking at other keywords involve stationary, Newton's first law. But when then we are introducing keywords such as accelerates, then you know that you're dealing with the second law, because we know that in the first law there is no such as the object will accelerate. Why? Because of the net forces equals to 0, so it will maintain its original position. I hope that was clear enough. And if it's not, and you need me to go through over something, or you have questions, please do contact us on the WhatsApp line that you see below the screen, which is the 079 578 2908. Once again, 079 578 2908. Now, the most important given in any exam, which is the data sheet. The data sheet should be your best friend. You should be able to know how to use it. It's given, it's there, and a lot of marks come just from copying the formulas as they occur on the data sheet. So when you're looking at, for example, now we're dealing with forces, these are the formulas that you need to familiarize yourself with that have to do with forces, everything regarding Newton's laws, forces and Newton's laws. These are all the data sheet. These are all the formulas that you have on the data sheet. Remember, when we are looking at the Newton's laws, there are 4 Newton's laws, where 3 is about motion, and the other one is regarding the gravitational, universal gravitation. So why am I showing you the data sheet? You need to know how to read the question and understand. Read it with the intention of understanding. After understanding, you need to know how to pick the correct formula for the problem given. Please apply the correct one. And believe me, it is a mark for you to just copy the formula as it is, copy it as it is on the data sheet, regardless of what the problem is. Please do not rearrange the formula to suit what's needed, but rather copy it as it is. If you're asked to calculate, for example, acceleration, and you're using F net is equals to ma, this is how you get your marks, ma. This is a mark on its own. Do not rearrange it and write it in a form of making a the subject of the formula, where you have a is equals to F net over m. Write it like that. This is a no mark for you. This is definitely a mark. So when regarding the data sheet, copy it as it is. So here is basically a mind map that helps you understand Newton's law, or rather Newton's second law in this instance. The first thing that I always tell learners is that be able to define it. Define. Simple 2 marks as it is on the exam guideline. Define Newton's second law. Be able to define it. So Newton's second law, when you define it, it is already simple 2 marks for you. So when we're looking at Newton's second law, we're looking at what? When a resultant net force acts on an object, the object will accelerate in the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. What does that tell you? If the object accelerates, and it accelerates in the direction of the force, and the acceleration is directly proportional to the force, meaning that if you increase the force by 1, so will acceleration increase by 1, a factor of 1. If you increase the force by a factor of 4, the acceleration will increase in a factor of 4. But then the second part says that, and the acceleration is inversely proportional to the mass of the object. What am I saying here? So if the mass of the object increases by 4, acceleration will decrease by 4. That is an inverse relationship. So if one increases, the other decreases. That is inversely proportional. When we say it is directly proportional, it means that if we increase one factor, in this instance we increase the force by 2, then acceleration will increase by 2. Now, okay, let us analyze this. So if we're looking at Newton's second law, and we know that the object accelerates in the direction of the net force, and the acceleration is directly proportional to the net force but inversely proportional to the mass, what does that entail? It entails that a net force acts on an object. So we know that a net force needs to act on an object. So that tells you that the net force cannot be equals to 0. This is not the same as Newton's first law. We know that in Newton's first law, the net force is 0. There are forces that are acting on the object, but they just sum up, or they just add up to 0. In this instance, the net forces do not add up to 0. So what are we saying? We're saying that the forces acting on the object are therefore not balanced. Obviously, because there is a force. They are not balanced. If they were balanced, they would cancel each other out and therefore would have a 0 net force. So they are not balanced. What does that tell us? It tells us that the net force therefore causes the object to accelerate in what? In the direction of that force. So if you give, for example, if you find a trolley in a shop standing and you just give it a push, what will happen? The trolley will accelerate in the direction of the force. You give it a push, then it will accelerate in that direction. In this case, if it's right, it will accelerate to the right. So the net force will cause the object to accelerate in the direction of the force. And the acceleration and net force will therefore go in the same direction. That is very critical. It will go in the same direction. Remember, acceleration will go in the same direction as the net force. And there is therefore a change in velocity. If there's a change in velocity, it tells you that the initial velocity will not equal the final velocity. In an instance, remember when I showed you the velocity time graph and I had a constant velocity there was my VI was equals to my VF. In this instance, that is not the case. VI will not equals to VF because there is a change in velocity, meaning that the object is accelerating. Remember, acceleration is what? It's change in velocity. So therefore, acceleration will never be 0 meters per second. Let us now look at the relationship between acceleration and the force, as well as the acceleration and the mass. So there are two relationships when we're looking at acceleration in terms of Newton's second law. There is a relationship of direct proportionality between acceleration and the net force. And the other one is there is an inverse proportionality relationship between the acceleration and the mass of the object. So what are we saying in terms of the direct proportionality? When acceleration is directly proportional to F net, what does that entail? It means that if we increase the force, therefore acceleration will increase. If we decrease the force, the net force decreases, so will the acceleration decrease. So the greater the net force, the greater the acceleration, and the opposite is true, which is the smaller the net force, therefore the smaller the acceleration. How about the inverse proportionality in terms of the mass and acceleration? Remember, when we say that there is an inversely proportional relationship, we are saying that if we increase one factor by 1, the other will decrease by 1. So here we are looking at the greater the mass. If the mass of the object is greater, what will happen to the object's acceleration? It will be smaller. The smaller the acceleration. So the smaller the mass, and the opposite is true also. The smaller the mass, what happens? The greater the acceleration. Think of it like this. If the mass is big, it's heavy, so it finds it very difficult to accelerate. But if the mass is smaller, it finds it easier to accelerate. Right. So now let us look at what your exam guidelines requires you to know about Newton's laws. So you should be at a position where you'll be able to define Newton's laws and also not just understand and define them, but apply the application of Newton's laws. By now you should know we did different forces this year in grade 11. You should know the different forces that are applicable in terms of Newton's laws. Then we are looking at weight, right? We're looking at the normal force, and we will look at them using free body diagrams as well as your force diagrams. So when we're looking at weight and normal force, these are normally they work opposites to each other, right? Then we have frictional force. So when we're looking at the normal weight, we are looking at the normal force, we are looking at the force that is exerted by the surface of the object, basically. So it's exerted by the surface that the object finds itself on. When you're looking at the frictional force is basically the force because due to the material that is used on the surface that the object will be on. And then frictional force basically has we did this also this year. Remember, if you can recall very well, we did the static frictional force as well as the kinetic. The kinetic occurs when the object starts to move, where the static is when the object hasn't started moving. And then we have the applied force. The applied force can be in a form of a push or a pull mode. Then we have tensions, and the tension is normally when we connect either two it's when we're looking at tension, is when we're connecting either two objects or we're subtending something on a string, hanging it from somewhere with a pulley in this case. And when we're looking at tension, you'll see in most cases for the purpose of your grade, we normally talk about inextensible, meaning that it doesn't stretch, or rather we'll talk about it's massless, meaning that you need to ignore the mass of that tension string or cable that was used. Then we talk about, let us now define the normal force. So the normal force is defined, and you should be able to define it, right? In metric, guys, you go into metric. So normal force is defined as the force or the component of a force which a surface exerts on an object. So we're looking at the force that the surface object exerts on an object which it's in contact with, and it is perpendicular to the surface. So we're looking at, this is my surface, and if I place a box there, the normal force is this would be my normal force, and it is perpendicular to the surface rather, and it is that force that is exerted by the surface we place the object on. Right. And then frictional force, once again, frictional force is basically a force, should be able to define it too. It's defined as the force that opposes motion of an object and which acts parallel to the surface. So if I apply a force to the right and the object starts to move, in this case my trolley, the surface that the trolley wheels are moving on will apply basically what? A frictional force, where it will be opposing motion, so it'll be in the opposite direction. Remember, when we're dealing with forces, we said that forces are what are vectors, so the direction matters. Remember, direction should matter. So it will, if my motion is to the right, then the frictional force will be to the left. So in this case, if we're looking at the sign of the force, it will take upon a negative sign. Right. You should be able to draw both your force diagrams and the free body diagrams. What is the difference? The free body diagram tells you it is free of the body. We're just looking at the dot. So we're stripping away the box from its box shape, and we're just using a dot in this case. So it is free of the body. And a force diagram basically is the one that shows the whole body on it. If it's a box, you will draw the block and you'll show all the forces. But in both cases, you need to show all the forces that are applicable. So regarding this, you should be able to know how to draw force diagrams. You should be able to know how to draw free body diagram, and this is a diagram that shows the relative magnitude and direction of the forces that are acting on the body or the particle that has been isolated from its surrounding. Once again, it's free from the body. So we're just looking at the object represented by normally a dot, and then we are putting all the forces that are acting on that particular object, removing the surroundings that may affect it. And then you should be able to resolve a two-dimensional force such as weight on an object and at an inclination. So remember, there are two important, when we're looking at inclination on an inclined plane and we're trying to resolve the components, there are two formulas that you do not find on your formula sheet that you need to remember. There's something called the FG parallel and the FG perpendicular, right? One is the x, or FG parallel will be my x, and the FG perpendicular will be my y. These are these two, and we will get to them when we do them extensively. These are just want to put it out there that these are not on the data sheet. Please, you need to know them. You need to learn them, know them off by heart, where you will have where you will have basically the force to the sine of theta, which is the theta will be the angle of inclination in this case. So please familiarize yourself with these and also learn them, because they're not on the data sheet, and we will get to such examples. And then you should be able to determine the net or the resultant forces of two or more forces. Normally they'll give you a problem where you have an applied force at an angle, or you'll have a box that is moving at an inclination. So you need to find the components so that you can get the resultant forces if it's either on the horizontal or the vertical, depending on the problem that you are confronted with. And we will get to such problems where you will need to find the different components. And when we get to Newton's second law, you should be able to state the Newton's second law of motion. And how do you state it? This is the one that will be marked. This is the one that is on the exam guideline. This is the definition that you need to learn off by heart. A simple 2 marks. Normally, when you are confronted with these questions, the first question will ask you to define the Newton's second law of motion. And then you should be able to define that when a resultant or a net force acts on an object, the object will accelerate in the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass of the object. We've been emphasizing this whole morning regarding the direction of acceleration and the proportionality relationships in terms of, is it direct or is it inversely direct? Is it inversely or is it a direct proportionality? So when we come to the Newton's second law, when you state it, you cannot put it any other way. It's 2 marks or nothing. So when we are dealing with Newton's second law, or Newton's law of motions in this matter, drawing the force diagram and the free body diagram of the objects are very, very important. You should be able to draw them when they are in equilibrium or accelerating. So you should draw force diagram and free body diagrams for objects that are in equilibrium or those that are accelerating. And then what happens after learning how to define them, understanding that, okay, we are, when it's the first law of motion, we're looking at constant velocity on object at rest, where the net force is equals to 0. When we're looking at the second law of motion, the Newton's second law of motion, we're looking at an object that is accelerating because of a net force that is not equals to 0. So then how do we apply this? You should be at a position where you need to know how to apply. Applying is also very, very important, because that's where you actually get most marks from, applying these laws in terms of calculations. So applying Newton's laws of motions to a variety of equilibrium or non-equilibrium problems, including a single object that is moving on a horizontal plane with or without friction. Not only that, but a single object that will be moving on an inclined plane with or without friction. When you're looking at the one that is on a horizontal plane without friction, when we have, in this instance, if we're looking at a horizontal plane without friction, but the applied force, it's moving, for example, in this direction, we have an applied force. So this is basically what? A single object. That's my single object, right? And then it is moving on a horizontal plane with an applied force, and there is no friction, or it could be a frictionless surface. That they will tell you it's a frictionless surface, or they'll say there is friction, or we'll be looking at one that is on an inclined plane, where they'll either say that it's a smooth surface or there is friction. And then we also have one where we're looking at moving in vertical plane, like for example lifts, extendable, they'll tell you about a rope, an object that is subtended by a rope, or rockets. Those are the vertical plane. And also and then these are all the single objects. So you'll either have a horizontal plane with or without friction, an object that is on an inclined plane with or without friction, and an object that is subtended vertically on a vertical plane. Then you can also be confronted by questions or problems that will include two body systems, right? We have one where it's just a single object, and then this is just a single object, and then we have one where there will be two body systems, and they're normally joined by a light inextensible string. Remember when I said inextensible, they're telling you that it does not stretch. So it moves as a system. So as the one block moves, so does the other one moves. The string that attaches it does not in any way stretch. So also you need to look at the word light, meaning that we are disregarding the mass of the string. The string basically is massless. We're not looking at the mass of the string. So in this case, where you have two body systems, so it will be both on a flat horizontal with or without friction. So in this case, it will be both flat in this manner with or without friction, or we'll have one on a horizontal plane with or without friction, and the other hanging vertically from a string over a frictionless pulley. So in this case, we'll have one on the table. So we'll have a table. In this case, I'm just giving a scenario here. So for example, we have one on a table, and then it will be hanging with a pulley, in this case hanging one other box in this manner, something like that. So this is on a horizontal plane, and this will be hanging vertically. So that's the two scenarios that you can get when you're looking at the two body systems. And then the last one is that both on an inclined plane with or without friction. So the last one would be something like that. So where they are both joined on an inclined plane, where there'll be friction or no friction. So these are the three scenarios or problems that you can be confronted with, where you will need to apply the Newton's laws of motion. So the first one would be in single objects, where you'll be looking at horizontal plane with or without friction, inclined plane, so there could be a horizontal plane, inclined plane with or without friction, or the one that is just hanging, in this case, like shooting up a rocket or a lift, an elevator. The second one is when we have two systems, right? Two bodies, in this case, one system, two bodies. Yes, so one system, two bodies that are joined by a light inextensible rope or cable or string. What does that mean? It means that the string does not stretch. So it will either be, they'll be both flat on a horizontal surface, or one will be on a horizontal, one will be hanging, or the last one where they'll be both on an incline. So those are the three problems or scenarios that you can be confronted with, and you should be able to apply these. And lastly, both hanging vertically from a string over a frictionless pulley. In this case, you'd have something like where they are both hanging. So when this one goes up, this one goes down in that manner. So those are the four cases that we deal with when we're having two systems, two body systems. Right. Remember, we've been dealing with forces and the Newton's law. And I said that when you're confronted with a question, please look at keywords such as rest, stationary, or acceleration. And normally when you're dealing with acceleration, it is what? It is Newton's second law of motion. So what about acceleration do you know by now? You know how to define acceleration. You know that acceleration is what? It is the rate of change of velocity, right? It is basically represented in this manner, where A is equals to your change in velocity, your final velocity minus your initial velocity divided by the time, the change in time. What are the units for acceleration? The units for acceleration, we know that it's meters per square seconds. How? Why? Because we know that velocity is meters per seconds and we have time, which is per seconds. So that's where the 2 will come in this case. So we have -1 and then we have 1. So if we take this up, then we have m1 ms minus 2. That's the unit for acceleration. So there is a linear relationship between acceleration and net force. We saw this in Newton's second law of motion, where we said that the relationship is proportional, meaning that if you increase your net force, you increase acceleration by the same factor. So this relationship can be written as a proportionality statement. What are the statements? The statement says that acceleration is directly proportional to the force, the net force. Or you can literally say that the acceleration is directly proportional to the resultant force. So a net force exerted on an object may make the velocity of an object to change, right? So a net force, if we apply a net force on an object, we can make the velocity of an object to change. Remember, acceleration is the rate of change of velocity. So when we're applying a net force and there is acceleration, that means there is a change in velocity. And since a change in velocity is acceleration, we can say that the net force causes acceleration. Do you understand that, grade 11s? If we exert a net force on an object, what happens? We change its velocity. And we know that a change in velocity is acceleration. So, meaning that applying a net force on an object causes that object to therefore accelerate. Why? Due to the net force. Does that make sense? So, that is as far as the relationship between acceleration and net force. And yes, we represent it mathematically by showing the proportionality rate of saying that acceleration is directly proportional to the net acceleration is directly proportional to the net force. So there is a linear relationship between acceleration and the reciprocal of mass. This relationship can be written as a proportionality statement where we have acceleration is inversely proportional to the mass. You see that? And what does this say? We know that if acceleration increases, we know that that means that the mass has decreased. So if we increase the mass of an object, the acceleration of that object will therefore decrease. So the proportionality statement that acceleration is directly proportional to the net force and inversely proportional to the mass can be combined into one statement where we look at, in this manner, we have acceleration is directly proportional to the top part, which is the net force, but inversely proportional to the mass at the bottom. So it is inversely proportional to the mass. So if we increase the A by 1, the F net will increase by 1, but the mass will decrease by 1. Or we can represent it by saying K is F net divided by the mass, and the K is basically the proportionality constant. And since 1 N is defined as the net force required to accelerate 1 kg object at 1 meters per square second, K is equal to 1. So basically what this statement is saying is that we're looking if we are applying a 1 Newton net force that accelerates a 1 kg object, that means that the acceleration will be 1 meters per square second. And therefore K is equals to 1. So the reason why in this instance the K is not written is because of we see that it's we apply a force of 1 Newton to a mass of 1 kg of an object. So the acceleration in this case will be 1 meter per second. And then k is equals to 1. So the equation can be written just in this manner, right? Because we know that k is equals to 1. And this mathematical relationship is known as the Newton's second law. So that's how we come across Newton's second law. And the Newton's second law of motion can be formally stated as follows. When a net force, F net, is applied to an object of mass m, it accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass. And the equation used to calculate Newton's second law of motion is F net is equals to ma. F net is equals to ma. Remember when we saw in the previous slide, we saw that acceleration, so if we divide by m on both sides to get rid of the m here, what we'll have a is equals to F net over m. And we said that the net force is directly proportional to the acceleration, but inversely proportional to the mass. Do you see that, grade 11s? Once again, if you have any questions and you'd like me to go through something again, do contact me on the WhatsApp line that you see below the screen. That is the 079-578-2903. Right. So the net forces is the vector sum of all the forces. So when we're looking at the F net, we're not just looking at the applied force, but we're looking at all the forces that are acting on a certain plane, either the horizontal plane or the vertical plane. So we are looking at, for example, the applied force and the frictional force, or probably the tension force that are maybe acting on that particular object. And that is basically our F net. All the forces added up. And remember, they need to have direction. If you choose applied force to the right, meaning that the ones that are acting opposing motion will go to the left. So remember, you always need to give direction to these forces. With that said, grade 10, grade 11s, I have an exciting group activity for you to do here, and I would like to give you 3 minutes to complete this activity just by using basically we're dealing with acceleration, right? And the proportionality relationships between acceleration and mass and force and acceleration. So I would like you to apply that knowledge right now in answering these questions. I'll give you 3 minutes to do this on your own, and then we will come back to discuss. You may discuss as groups, you may do it individually, it's up to you, but just use the knowledge regarding the relationship in terms of F net is equal to the relationship between. So basically we're looking at the relationship between acceleration and the force, as well as the acceleration and the mass. See you after 3 minutes. Welcome back, grade 11s. I hope the time was enough for you to go through these problems and get to a solution. Right. So the first one says, okay, what happens to acceleration of an object if the mass of the and the net force both decrease by a factor of 4? Right. So we're looking at what happens to acceleration when if the mass and the net force decrease by a factor of 4. So we are looking if the force, let's work with them separately. Remember I showed you the relationship of acceleration and F net. We said that it's what? It's direct. And I said that the relationship between acceleration and mass, it's what? It's indirect in this case. It's inversely. The inverse relationship. So let us work with one factor first. So now, if I say that my net force decreases by a factor of 4, what am I looking at? I'm looking at it decreases, so it'll be 1 over 4. That'll be my F net. What does that entail about my acceleration? What does that tell me about acceleration? We say that it is directly proportional. So meaning that even acceleration will decrease by a factor of 4. Now we say that also, then now the mass also what? It decreases by a factor of 4. If mass decreases by a factor of 4, right? What does that tell you about acceleration? Acceleration will increase by a factor of 4. So we'll have a 4a in this instance. It will increase by a factor of 4. So if you look at this overall, look at this part. What does that tell you? We decreased force, that means acceleration decreased by a factor of 4. But then we decreased mass, meaning acceleration increased by a factor of 4. What does that tell you? That they basically neutralized each other. So A remains the same. In this case, A, it remains the same. It did not change. Why? Once again, we decreased it by a factor. We decreased force by a factor of 4, meaning that acceleration also decreased by a factor of 4. But we increased mass by a factor of 4. Sorry, we decreased mass by a factor of 4, increasing acceleration by a factor of 4. So we had a decrease by a factor of 4 and an increase by a factor of 4. So if you say a quarter times 4, that would give you what? 1. And so A remains the same. Let us look at number B. Number B says, what happens to acceleration when the mass and the net force both increase by a factor of 4? Should I give you a minute to quickly fix it regarding the fact that we just did number A? Let me just give you a minute to just go back using the same method where if here we decreased by a factor of 4, meaning that acceleration also decreased by a factor of 4. We decreased the mass by a factor of 4, but acceleration increased by a factor of 4. A remained the same because the factors of 4 neutralized each other. So I'll give you a minute to just quickly fix B, C, and D. See you after a minute. Welcome back, grade 11s. I hope you were able to fix the other 3. So let us look at number B. What happens to acceleration if the mass and the net force both increase by a factor of 4? Let us first look at the net force. So So we are increasing F net by a factor of 4, right? What happens to acceleration? It will increase by a factor of 4. And then we are increasing mass by a factor of 4. What happens to acceleration? It will decrease by a factor of 4. So basically, you can just, this is as good as saying 1 over 4a, right? It decreases by a factor of 4. What does that tell you? We increased force by a factor of 4. Acceleration increased by a factor of 4. But then we increased mass by a factor of 4. Acceleration then decreased by a factor of 4. What happened again? A stays the same, remains the same. It's the same as the top one in this case. We just decrease here, we just increase. So it remains the same because of what? The inverse proportionality. We increase force, we increase acceleration, but if we increase mass, we decrease acceleration. So it's like, okay, we take acceleration as, for example, acceleration is, I increase my net force by a factor of 4. I put acceleration there. But at the same time, I increase my mass by a factor of 4. What happens? Acceleration will drop by a factor of 4. So it goes back to where it was originally. Then it stays the same. Let us look at C. C is quite an interesting one. What happens to acceleration when the mass increases by a factor of 4, but the net force decreases by the same factor? We can start with the mass, you can start by the force, it doesn't really matter, but let's be consistent, we've been using F net first. So, right. We increase mass by a factor of 4, but then net force decreases by the same factor. So we're decreasing it, so we are decreasing by a factor of 4. What does that tell you? Acceleration will also decrease by a factor of 4. So in this case, we have a quarter of the net force that we initially had, and therefore that means that we will have a quarter of the acceleration. But we increase the mass by a factor of 4. When you increase the mass, what happens to acceleration? It decreases. So acceleration would decrease by a factor of 4. So we have, in this case, what do we have here? So, okay, let me write it like that. Okay, so I have A that decreased by a factor of 4. And then here I'll write it as my 4m is equals to, so only interested in the acceleration part. So I have acceleration that is A. So I'm looking at this. What do I now have? I have acceleration that decreased by a factor of 4. And it again decreased by another factor of 4. So it's like 4 times 4. And 4 times 4 we know is therefore 60. So this would be 1 over 16. So it decreased. So in this instance, acceleration therefore decreased by a factor of 16. So acceleration decreased by a factor of 16. Do you understand that? Why? We decreased net force by a factor of 4. Acceleration will decrease by a factor of 4. At the same time, we increase the mass by a factor of 4. But there's an inverse relationship. So meaning that acceleration will also decrease. We increase the mass, we decrease the acceleration by a factor of 4. So it's basically 4 times 4. So we decrease acceleration by decreasing force by 4 times 4, which is what? We increase mass by 4, therefore we decrease acceleration by 4. So it will decrease by a factor of 16. Do you understand? Right. The last one says the mass decreases by a factor of 4, and the net force is 0. Remember, if the net force is 0, how did we come about Newton's second law? We say that acceleration, the net force causes an acceleration. It was in the last statement in the previous 2 slides. So here we go. So we say that because of this acceleration, A is directly proportional to the net force, and inversely proportional to the mass. So when we looked at the relationship here, let me just in the statement, we said that it causes, so therefore we say that since a change in velocity is acceleration, we can say that net force causes acceleration. Do you see that? There's a change in velocity. Net force, what? Net force causes acceleration. So if we say that there is no net force for D, there is no net force, what does that tell you? It tells you that there's no net force, therefore acceleration in this instance would be 0. No acceleration. Once again, why? No acceleration because of the net force is 0. Does that make sense, grade 11s? I hope it does. Remember, no force acting on the object doesn't have reasons to accelerate. It's like when you find a trolley in a shop. If you don't apply a force to it, it's not going to accelerate, right? In this instance, if there's no force, since net force causes an object to accelerate, no force, no acceleration. So in this case, there will be 0 acceleration, no acceleration. Right. I hope that makes sense. And if you still have questions, once again, do contact me on the WhatsApp line that you see below the screen, which is the 079 578 2908. This brings me to the multiple choice questions. How to tackle. So these are just strategies on how to tackle multiple choice. The first and foremost important point is to start by carefully reading the question. When you read the question, don't read it in order to try to remember, or rather try to connect it to something that you have seen before. It may look familiar, it may look similar, but there could be a trick or a change to the question. So start by reading the question carefully with an intention of understanding the question. Don't read it for the sake of, we say read, but read with the intention of wanting to understand what exactly is asked of me here. And the second thing is that you need to underline the keywords in the equation, in the question, sorry. Why are we saying underline the keywords? Because they will help you bring you to the position of knowing exactly the concept that you are being questioned. So if you underline, for example, I gave you a keyword for example, at rest or constant velocity, you will know that we are looking at something to do with Newton's first law of motion. So underline keywords, they help, they assist you in actually getting to the solutions. The third one is pay attention to words that are capitalized. They can be either in bold, in italics. These words are basically telling you about the concept. This is the concept that you need to focus on. Those words that are capitalized, or they are bold, or in uppercase, or in italics, those are the words that actually tell you the concept that you need to be focusing on. So when you are reading your multiple choice questions and you see a capitalized word, know that that is the concept that you need to be focusing on. And then you need to decide whether you are required to recall. When you're recalling, it's either you know or you don't know. So you need to just remember or use a fact or phenomenon, definition, unit, or formula. So the question itself will tell you that this is either the application of the definition or the basically expanding on your understanding, or are we looking at the units of a quantity or the formula thereof. So decide whether you're required, and the decision will come from understanding the question. You read to understand. The decision of what's asked will come because if you understood the question, you notice the keywords, and you also, if there are capitalized words or italic words, then you will know that, okay, this is the concept, so what is needed of me? Do I need to recall the definition in this instance, or do I need to apply it, or do I need to basically write the formula of this definition, or so on and so forth? So these are part of the steps on how to tackle your multiple choices. The fifth one is first eliminate the answers that are obviously incorrect. Be careful not to eliminate the right ones. With multiple choice, you always know that, okay, if we are dealing, for example, with Newton's law, and they talk about if the option has something to do with rest or constant velocity or stationary, you can immediately eliminate that one because you know it has nothing to do with the concept that was asked. So eliminate the answers that are obviously incorrect. And we will put this to practice because I have here a multiple choice question that I will do with you. Then I will give you the second one to do on your own using these tactics on how to answer multiple choice. And also a part of multiple choice questions. Remember, multiple choice is 10 questions, 20 marks. Please allocate enough time. So you cannot do your multiple choice under 10 minutes because some of those questions, as I've already indicated, they are an application. An application requires more time to think, have that time to think and make a good decision. So use your time effectively. Allocate enough time for multiple choice. Don't think that because it's multiple choice, I can just run through it. You need to think of some of those. Some questions are pretty obvious, they're straightforward, but others, they will need application. So please use your time effectively. With that said, I have a multiple choice question for you to do. So we will use those steps together, and then I'll give you the second question where you will do it on your own. So here it says that a wooden block placed on a table is pushed, causing it to accelerate. So I'll underline accelerate. Which one of the following statements regarding the frictional force is correct? Right, a wooden block. So here we don't have so okay, the one that is capitalized is one, so we're only looking for the one correct statement. The others are incorrect. We know that, and we're reading the question, we understand that it's a wooden block, it's placed on a table, it's pushed, and it's causing it to accelerate. I've underlined accelerate. We're looking at Newton's, basically we're looking at Newton's second law of motion in this case, because it's accelerate. And which one of the following statements regarding the frictional force is correct? So now we are looking at frictional force. Right. The first one, we need to eliminate the obviously wrong ones. Says that the frictional force is increasing as the speed increases. Do you know of a phenomenon or the concept that we have ever taught regarding that, regarding the relationship between frictional force and the speed? As far as we're concerned, frictional force is basically the force that is by basically the material, the kind of material that the object is moving on. So that does in no way have a relationship regarding the speed of an object. So the speed will move regardless. I mean, the speed of the object will change whether the frictional force, it doesn't matter what the frictional force has or does in this case. There's not a relationship between the frictional force of the certain surface and the object itself. So in this case, we know not of a phenomenon that explains frictional force regarding speed. Number B says that the frictional force is equal and opposite to the pushing force. So they're saying that basically we're looking at the kinetic frictional force because of the object is moving. It says it accelerates. So it says that the frictional force is equal to the pushing force, which is what the force that we applied. If these are equal, they're in equilibrium, what does that then say? It means that the force would not, the object would not therefore accelerate, right? So this is Newton's first law. We know that that is wrong. The next one says greater than the pushing force. So the frictional force is greater than the pushing force. Frictional force is greater than the pushing force. So we are looking at here in this instance, we are looking at the frictional force. So Fk is greater than the force applied. The frictional force is greater than the force applied. Would the block accelerate? No, it wouldn't. So in this case, the frictional force is not greater. Let us look at the last one. Less than the pushing force. If the frictional force in this case is less than the pushing force, which is your force applied, what would happen? It will cause the block to accelerate. So Let us read this in this case. So this is as good as saying what? The frictional force is less than the force that we are using to apply, and that's why the block is accelerating. So which one is then the correct one? D is the correct answer. So for every wrong one, there was an explanation regarding why it's wrong. I mean, when you analyze and you understand the question, you know what exactly you're dealing with. So you will know that if the answer, if A is not correct, why is it not correct? If B is not correct, you will know basically for an object to move, we know that the applied force what surpasses the frictional forces. So that's why it is able to accelerate, because the frictional force works, or rather it's exerted in the opposite direction of motion. So we know that D is correct. Right, with that said, here is another multiple choice question for you to do using those steps. So because of its multiple choice and it's rather you need to work it out, I'll give you 2 minutes and then we'll look at the answers together. Welcome back, grade 11s. I hope you were able to get to the correct answer using the strategies that we just provided. So this question says a block being pulled by a force F and moving to the left on a rough horizontal surface is slowing down. We already know the rough horizontal surface. We know therefore we have kinetic friction. It's slowing down. So if an object is slowing down to the left, what does that tell you about acceleration? It's therefore meaning that it's accelerating to the right in the direction of the frictional force. It's been pulled, moving to the left, right, but slowing down. Therefore, it's accelerating to the right in the direction of in this case, in the direction of Fk. So we need to look at the direction of the resultant force as well as acceleration. What do we know about the relationship between these two? They are directly proportional. So we're looking at we're looking at Newton's second law of motion. We know that F net, or rather the acceleration of the object will accelerate in the direction of the force applied, right? Of the force, of the net force. The acceleration of the object will be in the direction of that net force. So we need to look at options that say, or rather we need to eliminate options that don't have F net and acceleration in the same direction. And let's eliminate those because those are obviously wrong. We are looking at resultant force and acceleration, and we know that they are in the same direction. So let us eliminate the ones that say that they are not in the same direction That would be A, and that would be D. So we are left with B and C. We're left with B and C. So now let's get the correct answer between the B and the C. So now you're having a 50-50 chance of getting the question correct. So let us look at this situation. So we are having a block that is moving to the left but slowing down. When it's moving to the left but slowing down, it tells you that it's accelerating in the opposite direction, in the direction of the frictional force. And what is the direction of the frictional force? If it's going left, the direction of the frictional force would be right. Therefore, we know that the answer in this case would be that it's B. The answer is therefore B. Why? Because of we know that if it's moving to the left, the direction of acceleration will oppose that of motion in the direction of the frictional force. So in this case, B is your answer. Are you happy with that, grade 11s? Do contact me on the WhatsApp line once again if you'd like me to go over the explanations, which is the 079-578-2908. Right. So this brings me to free body diagrams. It's in the Newton's laws where you'll be most probably asked to draw a free body diagram. So at this stage, you should be at a position to distinguish between a free body diagram as well as a force diagram. There's a difference between a free body diagram and a force diagram. We've already laid foundation to talk about a free body diagram. It is free of the body, right? And a force diagram shows all the forces, including the body included. So a free body diagram is represented by a dot. And then you should be able to be at a position to label the normal force. And we said that the normal force is exerted by the surface on an object and it acts perpendicular to the surface. So if I have a surface here and there's my object, so my normal force is perpendicular. Let us try to avoid using the words such as the normal force acts directly upwards, because it can lead to some misconceptions when we're looking at an inclined surface. For example, if we have an inclined surface here and we have an object that lies like that, what is a normal force? This is my surface, remember? This is my normal force. So it acts perpendicular. So I need to write a right angle degree in this case. That would be my normal force. So do you see that it is perpendicular? It's not straight up, but it is perpendicular to the surface, right? And then we always label the forces using the correct symbols. And you can also check in the exam guidelines what are the acceptable symbols to label these forces. For example, we have the Fg, which is your force of gravity, and then we have your frictional force, and we have your applied force. So we can use your applied force for Fa. Your frictional force can be shown by using Ff, and in so on and so forth. And your normal force, please, it's always N. It's normal, capital N, to show that that's your normal force. And the vector must always touch the object and it must have direction, right? If we're looking at a free body diagram, it must the tail of the vector must touch the dot that is that free body diagram, and it must have direction because of it is a vector. So the arrowhead shows the direction at which it is going, either left, right, or down. It must have a direction in this case. And frictional forces, remember, they always oppose motion. So if the object is moving to the left, the frictional force will be to the right. If the object is moving to the right, the frictional force will be to the left. So don't forget certain things like that when you're labeling your free body diagrams or drawing your free body diagrams. With that said, I have a question for us to do together. So this question says, the force exerted by the girl on the couch causes it to move towards the door. The frictional force is present between the floor and the couch. Draw a force diagram indicating all the forces acting on a couch. What? Draw a force. They didn't say free body, so we're looking at the couch as a block in this instance, indicating all the forces that are acting on this couch. So let us have a look at what I'm supposed to do. So we represent, the first thing is to what? To represent the couch. So it's not a force, it's not a free body, so it's a force diagram. So I'm just looking at all the forces acting on the couch in this instance. So we have the normal. The normal is the one that will be exerted by the floor that the couch is on and is perpendicular to the surface. In this case, the surface is in this case there. And what must happen? The normal force will be perpendicular up, perpendicular to on the surface going up, and then we have the force of gravity. The force of gravity, we normally draw it from the center because of what we're talking about. The gravitational pull towards it's from the center of the object. So that is represented by the Fg. And then we have that applied force from the girl. Remember, she's pushing it towards the door. So that is my applied force in this case of the girl. And then lastly, we have the frictional force. Frictional force is there by the surface, and that is my F small. That is for frictional force. And that is grade 11's a simple drawing of the force diagram. So these are all the forces that are acting on the couch. Are you happy? If you're not, contact me on the WhatsApp line and I'll be ready to assist. So when we are looking at normal on a horizontal plane and applied, or rather normal at an angle when we're pulling or push. So in this instance, we have normal on a horizontal plane, and when F is applied, bringing a push or a pull at an angle. So my block or my couch is placed on a horizontal plane. And then I have an applied force at an angle, a pulling. In this case, it would be a pulling force at an angle, at an inclination. So at an angle, which causes a 30-degree angle. Normal force will still be perpendicularly up, where Fg will be there, and my frictional force is on the side. But now, in order for us to calculate for example, if we want to get the breaking up this into its different components, if we want to get the frictional force, we need to basically get the X component of the applied force as well as the Y component of the frictional of the applied force. And that's where we use, basically, it's either you're going to use this. Look at the difference. Here we have a minus, here we have a plus. So here we are looking at if we want to get the kinetic frictional force, we know that the kinetic frictional force is what? It's the constant, it's the coefficient rather, it's the coefficient of the kinetic friction times the normal. And in this case, what is my normal? Your normal is determined by the mgy minus this F sin theta. F sine theta will be the y component of this vector here. It will be the y component of this vector, so that will determine the normal force. In this case, when you want to look at the normal force, the normal force would be the normal mg, right, minus the component, that the y component that will be applied in this instance. On the other hand, this is for a pulling situation. If this is a pushing, we're pushing down. Look, it's the applied force is going down. This is when we are pulling, but when the applied force is in this case in this direction, so we are pushing. How do you then work out your normal, right? Your normal, you know, it's mg, right, plus that force that is coming, the y component in this instance. We're looking at the y component in this direction, so you are adding on that F sine theta. This F sine theta will give you the y component, but in this instance you will be adding it because of it's a pushing force. Don't forget the two. When you are having a pulling force, you will subtract the y component, but when you're having a pushing force, you will add the y component of the vector. So you need to break down the vector into the components and you add. Remember, I said that we're going to get to a point where you will need to find the components of the resultant vector. In this case, you're using sine theta, the force times the sine theta, and the theta is the angle of inclination in this instance. But when you are working with a pulling force, you will add that y component, you will subtract the y component, but when you're adding with a pushing force, you will add that y component of that resultant applied vector. I have a question for you to do, which says calculate the coefficient of kinetic friction, UK, if a 2 kg box is pulled on a horizontal surface on a horizontal force, with a horizontal force to the surface. The kinetic friction between the box and the surface is 5 Newton. So now calculate UK. Remember, I'll give you a hint and I'll give you 2 minutes to quickly complete this. That would be what? It would be how do you get this? Is in the data sheet. You open your data sheet, you see that the kinetic frictional force in this case, will equals to the coefficient times the normal. Now, I'll give you 3 minutes to quickly complete this. See you shortly. Welcome back, grade 11s. I hope you were able to do the calculation well. So remember, copying the formula as it is on the data sheet, that is a mark. I already stated that. Remember, it is a mark. It is allowed, and yes, you should do it, and it is a mark. Easy marks. So this is the formula, and I had already given you a clue there. So what's next? What's next would be to basically expand normal. What is normal? We know that the normal will be the mass times the gravitational acceleration. And do we know the mass of the object? Yes, it's 2 kg. Gravitational acceleration, that's 9.8. So what do you do after this? You need to substitute into the original equation. That is a mark. You do not rearrange it. Substitute into the original equation, and that will give you a mark. Then after substitution, then you can rearrange to work out the unknown, and in this case that the coefficient is 0.25. So that is your coefficient. Easy 3 marks. So remember, the first one is writing the formula. That's a mark. Substitution into the original formula. That's a mark. Then you work out your answer. Calculation of your answer. That is your 3 marks. Easy, 3 marks. If you still need me to explain how this came about, contact me on the WhatsApp line 079 578 2908. Right. So here I have another question. It says a 10 kg box is placed on a table. A horizontal force of magnitude 32 Newton is applied to the box. The frictional force of magnitude 7 Newton is present between the surface and the box. The first one says draw a free body diagram indicating all the forces acting on the box. Free body. Read. Free body. Do not draw a force diagram. The second one says calculate the acceleration of the box. The third says calculate the normal force. So I will give you, due to time constraints and almost at the end of the session, I'll just give you 3 minutes. I know it's not enough, but just for you to quickly familiarize yourself and do as much as you can to complete these 3 questions, and then we will come back to discuss the answer. And I know it's short, but it's because of time constraints. See you after 3 minutes. All right, grade 11s, let us look at your solution. So the first one says draw a free body diagram indicating all of the forces acting on the object. So here I have chosen to have my applied force. This is quite an open question, so I have chosen, doesn't tell you to which side does the box move, so I've chosen to have my applied force in this case to the right. So if then I have that to the right, then I'll have basically from my free body diagram. So a free body diagram is supposed to be a dot, and here's my dot there. Then I'll have the FA, which is my force applied in this case, which is of what? Of 32 Newton. And then the next thing is the frictional force of magnitude 7 that's present, so that will go in the, remember, it's opposing motion. If my applied force in this case, my object is moving towards the right, so the frictional force will oppose the motion, and that will be my frictional force. Then I will have the force that is applied by the force that is applied by the surface, called the normal force. And then lastly, I will have my Fg, which is the force of gravity. So there you have your 4 marks. So it's a mark for each of these vectors, right? The second one says calculate the acceleration of the box. Calculating acceleration, you know you're applying Newton's second law of motion. Acceleration, Newton's second law of motion, and that would be F net is equals to mass times acceleration. That is a mark for just writing that formula as it is from the data sheet. You substitute into the original. Do not rearrange. You substitute into the original. So I have my 32 applied force plus my frictional force. Remember, it's net. I'm adding all of them, but I also need to take into account the direction of this force. Friction opposes the applied, which is going to be the motion of where the ball is going to move. The box will move. So here's, I have a negative there, but it is right. I need to add them all together, and it is equals to 10, which is what? Which is my mass times acceleration, and then you then calculate it. After calculation, then you should get 2.5 meters per second to the right. Remember, acceleration is a vector, so it needs to have direction. Right, and then the last says calculate the normal force. We know that normal force is going to be the mass times the gravitational acceleration. You substitute that, and that will be 98 Newton. That is the normal force in this instance. Grade 11s, due to time constraints, I'd like to give you this as your homework to do, and hopefully tomorrow, enough time of the next session, we'll have enough time to just put the solution of this question, and then but for today, I'd like to leave this as your homework. So I'll give you just 30 seconds to copy this down and write it as your homework. Welcome back, grade 11s. Let us just quickly summarize our lesson. So what did we do today? We learned about the different types of forces, and in these forces we learned about the normal force, and we said that it's the component that of which the surface exerts on the object that it's in contact with. We learned about the frictional force, and force that opposes the motion of the object, and is always parallel to the surface, regardless of whether it's inclination or it's a flat surface. It is going to be the parallel component. When we learned the static frictional force as well as the kinetic frictional force, we said that the static is the force opposing the density of motion to a state, basically on a stationary object. So it doesn't move, but it experiences that force, whereas kinetic frictional force is the force that is experienced by an object during motion. Not only that, we emphasized mostly on Newton's second law of motion, and we even did calculation to apply this Newton's second law of motion. And I said that you should be in a position where you'll be able to define this Newton's second law of motion. Not only that, but be able to apply it. And how do you define it? We said that when the resultant or net force acts on an object, the object will accelerate in the direction of the net force. And the acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Lastly, we looked at the formulas that you need to use regarding forces as well as the Newton's law. And we said that using this data sheet, you copy it as it is. First, identify the correct one to use, copy it as it is, substitute into the original, then you can do your calculation. For now, grade 11s, thank you so much for watching this lesson. Please remember to sanitize your hands, wear your face masks at all times, and maintain social distance. I'll see you next time. Goodbye.